Hey, welcome to video 3. Congratulations for making it this far. This is probably the most important video to watch since this is the most advanced part of the assignment, these last couple problems, because we're looking at matrix multiplication in which the dimensions do not match. That is surprising. Okay, so I mentioned here, because matrix multiplication is not simply multiplying the corresponding elements, we can, in fact, multiply matrices with different dimensions, or as the book calls it, different orders. So how does that work? Well, since we take the elements in the row of the first matrix, for an example, in this example here of matrix multiplication, I would be looking at the numbers in the rows of this matrix, for example, the top row, with the elements in the columns of the second matrix, like in this one, the column here for my first top row, left column result. I can take, as long as I have the number of elements in the row, so I have two elements in this row. As long as I have the same number of elements in the column, two elements in the column, then I can do the multiplication. I just need to match up, this element and this element, and we're good to go, right? Multiply those corresponding elements, and we're okay. So notice how this first one is a 3, 1, 2, 3 by 2, 1, 2. And the second one is a 2, 1, 2 by a 1, 2, 3. So we got a 3 by 2, and actually 4, sorry. 3 by 2 and a 2 by 4. And yet I would be able to multiply those because I have two elements in each row and two elements in each column, and they would match, and I would work that out. Oh, well, thank you. You want to say hi to the kids?
Hi, kids. Love to see you when I was sick yesterday. Okay, I don't want to show this.
Okay, yeah. Keep your jammies on.
I'm just doing this because I was under my jammies, I think. Can you button them?
Okay, yep, I will. Okay, and we're back. All right, so I had to take a little break there to fix some jammies. All right, so I'm not going to do all this matrix multiplication, but I just want to point out how this would play out. So I'd have these three rows of the first matrix, so I would have three rows in my answer, right? And I would have like four columns to work with in the second matrix, so I should have four columns in my answer when I take each of the three rows and match it with each of the four columns in the second one, and so I should end up with a 3 by 4. Okay, and you notice how the way this plays out, they both have 2's here. The first matrix has a 2 as the columns, and the second matrix has a 2 as the rows. Okay, and you end up with the dimensions on the outside, right? So when I take a 3 by 2 times a 2 by 4, I should expect to end up with a 3 by 4. Even before I do all the multiplication, I could predict that. And I have to have these match because, again, I have to have two elements. I have to have the same number at least in the rows. So I need two elements in the first. These two elements in the rows, meaning there's two columns, matches two elements in each column, meaning there's two rows, right? So these two numbers have to match.
Daddy.
Okay, and we're back. And so I'm going to say I cannot multiply a 3 by 2 and a 4 by 2, because if I take the row with 2 elements, right, top row, 1, 2 elements here, and I got to multiply those with corresponding elements in this first column, for example. Well, let's see. I can take that -3 times the 1 for the first one, the 5 times the 0, but that's all I got. That's all I got in the, it's the only elements I got in the rows, and I have these 2 extra elements in the columns I can't do anything with. So that's not going to work. And you kind of see how, oh, there's 2 here, but there's 4 here. That doesn't match. That's not going to work. Okay, so you cannot do that matrix multiplication. It doesn't work. There's matrices. You can multiply matrices with different dimensions. However, the number of columns of the first matrix have to match the number of rows in the second matrix in order to do that. So this cannot work. And just a hint, there's probably going to be one on your assignment that's like that. That's not possible. I just would write not possible. I think that's what I did on my answers, but the book maybe would say not defined due to the different order or dimensions. Okay, and we're back one more time. This is an arduous process, so we got the little blueberry muffin from Anna here. There it is. All right, so let's do one more example of matrix multiplication that is possible. This one is possible because I can see what we got here. We got a 1, 2, 3 by a 1, 2. So we got a 3 by 2, and I got a 1, 2 by a 1, 2, 3. Okay, so 2 by 3, and oh, there it is. Okay, those two match, and I should end up with a 3 by 3. All right, so let's see how this plays out. All right, so we'll take these row numbers by these column numbers first. Here we go. Let's do -3 times 1. Okay, we're taking -3 times 1. That's -3. And 5 times 2. Remember, we're working from left to right and top to bottom. But then 2 is 10. We're adding those together. And so here we go. I'm probably going to need a little more room here. But I'm going to write this down here. We got a little, I don't know how big I need to make that. That's going to be 7. First one is 7. Okay, so here we go. That one is done. All right, so now let's just move across the top, shall we? Let's go with top row and next column over, middle column. So -3 times 0 is 0. 5 times -1 is -5. Add that together, that is again -5. Okay, so there's that one. All right. Again, I should have a 3 by 3. It's looking like that's how it's going to shape up, because we're going to have the top row and just one more column. So -3 times 4 is 12, -12. There we go. And +5 times +7 is 35. -12 plus 35, I believe that is 23 down there. Okay. Move down just a little bit. All right, here we go. And now that should be the whole top row. Let's move down to the next one. Okay, we'll go back to purple. Here we go. Row 2. Go back to column 1. 2 times 1 is 2. -1 times 2 is -2. 2 plus -2 is 0. There we go. Okay. Let's go to the middle. Let's stay with the middle row and middle column. 2 times 0 is 0. -1 times -1 is +1. 0 plus 1 is 1. Okay, here we go. Sticking with the middle row. Last column. 2 times, start at the top, work your way down. 2 times 4 is 8. Negative 1 times 7 is negative 7. Negative 8 plus negative 7 is 1. 1, and that one's done. Okay, here we go. Bottom row. First column. 4 times 1 is 4. 7 times 2 is 14. Add those up, and we have 18. Bottom row, middle column. 4 times 0 is 0. 7 times negative 1 is negative 7. 0 plus negative 7 is negative 7. Sticking with the bottom row. Last column, third column. 4 times 4 is 16. 7 times 7 is 49. What is 16 plus 49? Well, we got 10 and 40, 50. 6, 9, 15. 50 plus 40 plus 15 is 55. There we go. Oh, nope, I was right the first time. 65. 10 plus 40 is 50. Plus 50, 65. There we go, 65. Okay, and that is it. That should complete my matrix. There's a 3 by 3. Okay, let's see how I did, because of course, you know your calculator can do this as well. So let's check our answers on there. Let's go down here. Okay. And actually, I'm just going to leave it on that page. So I got the answer right there. And I'm just going to move to my calculator over here on my computer. I'm going to go down at the bottom and look, there it is. Okay, I have entered those matrices into my calculator, and I'll show you that. Second matrix. And if I just pull up the name for matrix A, now remember you have to go over to edit to actually type the numbers in, right? And I put in a 3 by 2 matrix A. There's my matrix A, right? So go back to matrix again. If I just pull up name A and hit enter, it'll show you, oh, there it is. There's matrix A. Okay. Go back to matrix. Let's look at matrix B. There it is. There's matrix B. Okay. Now, I want to multiply those. I want to take matrix A. Actually, that's not the A on the previous problems, but I just used matrix A in the calculator. Matrix A times matrix B, number 2. There we go. And hit enter. That should hopefully be the same numbers we got in our work there. So we got 7, negative 5, 23. Let's check that out here. 7, negative 5, 23. 0, 1, 1, 18, negative 7, 65. I believe that's what we had. 0, 1, 1, 18, negative 7, 65. Okay, so that checks out. All right, so as always, let me know if you have questions. That completes the videos for section 6.4. 6.4. Okay. Have a happy Thanksgiving. We will jump into section 6.7. Yes, I said it's 6.7 when we come back the next Monday. Okay. See you later. Bye-bye. Say goodbye.
Bye. Happy to see you. I was sick. Just reminding you.
Say happy Thanksgiving, Anna.
Happy Thanksgiving, guys.
Happy Thanksgiving.